Good morning, everyone. So today we're going to be doing section 8.4. We're doing our first day on this section, which is on negative exponents. So I know in the last video we talked about how in that lesson you were allowed to leave negative exponents, but today, from this point on, you are no longer allowed to leave negative exponents in your answers. So first, let's talk about, well, what do those negative answers mean? And contrary to popular belief, a negative exponent does not mean a negative number. So it does not mean negative, so not a negative value. Instead, let's do a little exploration to see what it means. So let's start here. We have 2 being raised to the different whole exponents, different integer exponents. 2 to the 0 we know is 1. 2 to the 1 is 2. 2 to the second is 2 times 2, which is 4. 2 to the third is 2 times 2, 4 times 2 is 8. And then 2 to the fourth is 2 times itself 4 times. So 2 times 2, 4 times 2 is 8 times 2 is 16. So what is the pattern as we move upward from here to here, here to here, here to here, and here to here? Well, to get to each step, you multiply by 2. You multiply by 2, multiply by 2, multiply by 2. So what if we were to continue that pattern the other direction? So what if we look at it going downward? How do we get from 8 to 4, 4 to 2, 2 to 1? Well, instead of multiplying by 2, we divide by 2. So what if we were to, now we're going down to the negative exponents. To get to this one, we would divide 1 by 2 to give you 1 divided by 2, 1/2. And then divide by 2 again. But remember, dividing by 2 is the same thing as multiplying by the reciprocal of 2, which is 1/2. So what is 1/2 times 1/2? 1/4. So again, to the next one, multiply by another half to get 1/8. And we could keep going. So let's look to compare these. What is the relationship between 2 to the 1 being 2 and 2 to the negative 1 being 1/2? What's the relationship between 2 squared being 4 and 2 to the negative 2 being 1/4? And then the next one I'm not going to be able to fit on here, so let's just 2 to the third equals 8. 2 to the negative third equals 1/8. So then what is the relationship? Well, they're reciprocals. And that's what we're going to be summarizing on this next page. And that is that x to any negative n exponent, whatever n may be, is really just 1 over x to the positive n. And vice versa, x to the negative n being in the denominator, the reciprocal of 1 over that is x to the positive n. So all you have to recognize, this is how I think about it, is I like to put a 1 underneath any whole value, right? And anytime you have a negative exponent, the quantity with the negative exponent has to move to the opposite part of the fraction. And in this case, if it's in the numerator, it goes to the denominator and turns into positive exponent. And if it is in the denominator, it goes to the numerator and turns into a positive exponent. And that's it. But you have to make sure only the base being raised to the negative exponent is what's moving. If there's a number out in front, that coefficient stays put. So for example, if this was 2x to the negative n, that 2 would have stayed in the numerator. Only the quantity with the negative exponent moves. So let's try some. First, put this over 1, x to the negative n. So we're going to take that quantity and we're going to move it to the denominator. When we do that, the denominator becomes x to the positive 9, and 1 stays in the numerator. Number 2, x to the negative 2 has to move to the numerator and becomes positive, so x to the positive 2, and times 1 is just x squared. Now this next one, I'm going to put it over 1. Now let's pay close attention. Only the x to the negative 10 is being moved. That's the only item with a negative exponent. 2 has an exponent of 1, so we don't want to move that. Only move the highlighted portion. So that stays 2 in the numerator and now becomes x to the positive 10 in the denominator. All right, next one. Y to the negative third has to go up. That's really large, but and then x to the negative 10 has to come down. So then y to the negative third becomes y to the third over x to the 10. Now, can I simplify this further? No, because the bases are not the same. Remember, keep the base and then do the work to your exponents. But if they're not the same base, that's all you can do. Just leave it like that. Now this next one, which one has the negative exponent? Well, that's just the denominator of y to the negative 3. So then that has to come up to the numerator. Oops. Up to the numerator. And we keep x to the 10. Y becomes y to the third. Again, not the same base, so you can't combine them. So those are the answers for those 5 problems. So now let's try to tie together some of our other rules as well. So we have a power raised to a power. So when that happens, everything in that base is getting raised to the 5th. So you keep your base and you multiply your exponents. So that becomes x to the 2 times 5 and y to the negative 3 times negative 5 rather, and negative 3 times negative 5. So when you multiply 2 and negative 5, you get x to the negative 10. And when you multiply negative 3 and negative 5, you get positive 15. Can we leave our answer like that? No, because x has a negative exponent, right? So we're going to take that x to the negative 10, and we're going to bring that down to the denominator. And when we do that, y to the 15 stays in the numerator. Remember, only move the item with the negative exponent, and x to the 10 goes in the denominator. Again, not the same base, so we are done there. All right, next problem. So first, I want you guys to remember, you still have to simplify any coefficients that we have. So 51 is still getting divided by 17. And when you divide those, you should get 3, regular 3. So we're going to keep it in the numerator. So those become 3. If you put it in the denominator, that's 1/3. So make sure that goes in the numerator. Next piece we need to look at are the x's. So I'm highlighting the x pieces. We're dividing. What do you do with your exponents when you divide? You keep your base and you subtract your exponents. So x to the 6 minus 2 becomes x to the 4th. So I'll color coordinate this for you. The green was the 3, the x to the 4th was the yellow, and now let's look at our y's. Now there's two ways you can do this. I personally, now that we know our trick, I always like to move anything with the negative exponent. So although you can just go ahead and subtract these and then move it, what I personally like to do so I don't mess up any negative signs is I take whatever the negative exponent is usually and I move that first because I like to work with positives. And when you move that, it becomes y to the 10 in the denominator, right? Well, now we have y to the 12th times y to the 10th in the denominator. Multiplying, you keep your base and you add your exponents. So in that denominator, you now have y to the 22nd. And that's your final answer. But again, you still could have subtracted negative 10 minus 12 and gotten negative y to the negative 22 and then moved it downstairs. I just prefer to move things from the start. Okay, next one. Let's highlight our coefficients. We have 2 over 12. Both are divisible by 2. And you end up with 2 divided by 2 is 1. 12 divided by 2 is 6. So 12 over 2 is 1/6. Next, x to the 5th over x to the 6th. Now here is another trick that I like to use. I know I have to subtract them. When I subtract them, I have 1 left over, a negative 1 really, right? To figure out where that leftover x goes, it's always going to be where there's more. So which one has more, x to the 5th or x to the 6th? Well, x to the 6th has more. X to the 6th has more. So the leftover x is going to be in the denominator. Now, if you want to think about this in expanded form, x to the 5th is 5 x's being multiplied to each other over 6 x's being multiplied to each other. And then 1 pair, 2 pairs, 3 pairs, 4 pairs, 5 pairs are crossed out, and there's only 1 left over in the denominator because that denominator had the extra x. So there's only x left over in the denominator. And then again, if you would like, and I'm showing you lots of different ways you can approach these problems. If you would like, you can go ahead and move y to the negative 7 down and y to the negative 8 up. And when you do that, now you have y to the 8th in the numerator and y to the 7th in the denominator. And now it's a little easier to see. Well, we know we have to subtract them. When we do, we have 1 left over. But this time, where do we have the leftover y? In the numerator. The numerator has more. So that means we have 1y left over in the numerator. So let's see what we have left over. We have 1 and y in the numerator. I don't need the 1 though. I can just write it as 1, or y rather. And then I have 6 and x left over in the denominator. So 6x. And now we are done. Okay. This next problem, we want to write the following denominators in exponential form, and then we want to write them as a fraction with a negative exponent, okay? So I want to show you that these can be written as a fraction with a negative exponent and without. So look at the denominator. 4. 4 can be written as an exponent. 4 is 2 squared. So we could write this as 1 over 2 squared, or just like before, if we were to take anything and move it to the alternative, if it's in the denominator, we move it to the numerator, it'll change exponential signs. So since now it's positive, if I bring it up, it's going to become 2 to the negative 2 exponent. Next, let's actually do the 9 first. Let's do 1/9. 9 can be written as 3 squared. So now that's 1 over 3 squared. Now, again, what if we were to move that 3 squared up? Now it becomes 3 to the negative 2. And let's see, now that we've worked with this a little bit, how can we rewrite 8? 8 is actually 2 times 2 times 2. So that's really 2 to the third. And if we were to move that up, it would become 2 to the negative third. So I just wanted to show you that these fractions can be written as exponents with or without negatives. But again, we're not allowed to leave them as negatives when we're simplifying. All right, last ones. Okay, 30 over 5 is 6. X to the fourth divided by x squared. Subtract them, you get x squared left in the numerator since this one had the more. So your answer is 6x squared. All right. This next one tricks some kids because both of these are in parentheses, right? Which means you're going to be multiplying them, right? But which parenthesis, does the first parenthesis, the second parenthesis, or both have the exponent of 5? Well, the exponent of 5 only belongs to that second parenthesis. So please do not give it to the first one. So when we raise x to the 7 over y to the second to the fifth, we multiply our exponents. So that becomes x to the 35 over y to the 10. And then you multiply by that purple fraction of y over x to the 20th. And when you multiply those, okay, love this problem. 2 different ways you can approach it. You can just multiply horizontally if you'd like, but you can also cross cancel. So for example, x to the 35th over x to the 20th. X to the 35th is in the numerator, x to the 20th is in the denominator. So you subtract your exponents, you get 15. And where are the 15 x's left over? In the numerator. So we get x to the 15. Same idea with the y's. Y, which has an exponent of 1. We can write it in to remind us. So y to the first over y to the 10th. We subtract our exponents. We have 9 left over, but where are those 9 y's left over? They're left over in the denominator. So we have y to the 9 in our denominator. So our final answer is x to the 15 over y to the 9. Last problem. Every single thing in this parenthesis has to be raised to the 5th. So 2 gets raised to the 5th. X to the 7th gets raised to the 5th. Multiply the exponents to get x to the 35 over 3 gets raised to the 5th, and y squared gets raised to the 5th, so that becomes y to the 10. Now there's nothing we can do with these exponents here with the bases of x and y because they're not the same base, but we can simplify the values here. So you can just go ahead and type those into your calculator. I'm not going to make you do those out, but if we were to multiply them 2 to the 5th, that one's not bad to calculate, is 32, equals 32x to the 35th over, and then if you were to type into your calculator 3 to the 5th, it's going to be a little bit larger of a number, and that's 243, y to the 10. And there you have it. Your homework tonight is on Delta Math, so please work on that for the remainder of the period and finish it up for homework. Let us know if you have any questions. Email us. See us during office hours. Take care. Thanks.